Hello everyone, welcome back to Diksha Vedantu YouTube channel, and today is day 84 of 99% in 99 days, and I am going to discuss 5 most important concepts from your physics, from your entire physics syllabus of your science part. So don't go anywhere. Let's see one by one what are all the important concepts, and from there almost every year at least one question comes. Okay, so we will see some example questions as well. These questions, obviously all the questions I have chosen, it is a little longer. Some questions might be smaller, some questions might be longer like this as well. So but these concepts are super important for preparation of your final board exam. And if you want to quickly review all your papers, then this is the thing that you have to consider, right? Let's not reveal from where it came. Okay, so let's see the question. First question: a security mirror used in big showroom has radius of curvature 5 meter. Okay, if a customer is standing at a distance of 20 meter from the cash counter, find the position, nature and size of the image formed in the security mirror. Now security mirror is basically a convex mirror. Okay, it is not a concave mirror, it is a convex mirror. So first topic is spherical mirrors, and spherical mirrors, convex and concave, both can come. So you have to solve some numerical, you have to draw some ray diagrams. So that is the main part of this part. So here we have a concave mirror, and the focal length is basically given radius of curvature is given 5 meters. So radius of curvature is basically 5 meter. So focal length is basically divided by 2, so it will be 2.5 meter. Okay, it is given in meter, so simple SI unit is given. Next, the person is standing 20 centimeter from the mirror. So where its image will form? Its image will definitely form behind the mirror, right? Let's try to find that out. So this is given, u is given as equals to minus 20. So u is always minus, and as I told you, for convex surfaces it is positive, be it lens or be it mirror, and for concave it is always negative, be it mirror, be it lens, right? So 1 by v plus 1 by u equals to 1 by f. So let's put the value. 1 by v we do not know, so 1 by f minus 1 by u, or it is uf u minus f, or v equals to uf divided by u minus f. Okay, so this is the formula. You can directly put the values. U is minus 20, f is 2.5 divided by 20 in plus 20 minus 2.5, sorry. So this is the, you can calculate it. So it will be v equals to one more thing, u was minus, so here another minus will be here. Definitely v will be positive here. So minus 20 into 2.5 divided by minus 22.5. So this minus cancels, and then you can calculate the values. So this decimal gone. Then you can do what you can do is 25 is 5 4s are 20, 5 5s are 25, so it will be 5 9s are 45. Okay, so answer will be if you do this 2 by 9 is 2.2, so v will be 2.2 meters. Okay, so distance from the mirror, it will be 2.2 meters positive. Okay, that means definitely it is a virtual image. V sign positive means it's a virtual image for a mirror, right? And what is the size of the object? Okay, if it is size is given, customer is standing in the distance 20 meter from the cash counter, find the position, nature and size of the image. Size you cannot find, but you can find the magnification because size of the customer is not given, right? So magnification you can calculate. Magnification is basically minus V by U. So it is minus 2.2 divided by 20 minus 20. So minus minus cancels. So you will get 1.1 by 10, so that will be 0.11 times. So 0.11 times the original size of the object. And what is the nature? Nature, it's a virtual image. Okay, position is 2.2 meters, and also it is an erect image. Obviously, as we can see, the magnification is plus, that means it's an erect image. Okay, so I hope that clears all of your doubt. Next part, question number B. Neha visited a dentist in his clinic. She observed that the dentist was holding an instrument fitted with a minor state nature of his with a mirror, sorry, instrument fitted with a mirror. State the nature of this mirror and reason for its use in the instrument used by dentist. So whenever the dentist is using a mirror, that is a concave mirror. Concave mirror can show enlarged images when it is kept near less than focal distance. So that is why dentists generally use a concave mirror to check the inside of the teeth. Okay, now let's move on to the next question. This is from the chapter light again, but it is from spherical lenses concept. Again, spherical lenses, we have two types of lenses, convex lens and concave lens. Either any of them can come. Okay, immaterial of that. Sometimes spherical lens is combined with the next chapter, human eye. We will see some problem from that chapter as well. But you have to practice from this concept as well. Now let's see one question. Rishi went to a palmist. This is a case based question. Rishi went to a palmist to show his palm. So you know that that people who check your palm and tell your future. So he went to a palmist. The palmist used a special lens for this purpose. So they use a special lens to zoom in into your palm lines, and they can tell, okay, this is your future. This is how your future holds. So what is the state the nature of the lens and reason for its use. The nature of the lens is basically, it is a convex lens. Okay, convex lens. It is similar to that of the concave mirror. When it is held very close to the object, it produces an enlarged virtual image that helps us to detect all the lines in the palm. So basically it is a convex image, and it at a distance less than focal length, it produces enlarged images. Where should the palmist place hold the lens as to have the read and magnified image of the object? Obviously we know that the palmist has to hold the lens at a distance less than the focal length, so that it can produce a magnified virtual image. If the focal length of this lens is 10 centimeter, now it's a problem. 10 centimeter is the focal length, and the lens is held at a distance of 5 centimeter from the palm. Use the lens formula to find the position and size of the image. So we have to find the position and the size of the image. Okay, so 1 by V minus 1 by U equals to 1 by F. So as usual, we will try to simplify this as much as possible first. So it will be U plus F by UF. Okay, so V is basically equals to UF by U plus F. Now let's put the value. So U is given here at a distance of 5 centimeters. So you have to declare the variables first. So U is minus 5 centimeter, and F is given as 10 centimeter, and then it will be minus 5. Convex lens means focal length is positive. Okay, so just put the values. It will be minus 50 divided by plus 5. Okay, so it will be minus 10 centimeter. Okay, so minus 10 centimeter means definitely it's because it is negative, that means it is on the same side as the object, that means it's a virtual image. Okay, for lenses, if the object is same side, if the image is same side as the object, then definitely it's a virtual image, right? So it's a virtual image. Position, size is simple. Magnification basically is given by V by U. Okay, for lens, so V is minus 10, U is minus 5, so magnification is twice. Okay, so position and size we have calculated. Now if the size, if they ask you about size and nothing else is given, then basically you have to find the magnification. Okay, so that is the catch. Now next move on to the human eye, and the concept is here eye defect. So third concept is eye defect. Based on eye defect, at least one question will definitely come. It can be a 3 mark. Some cases I have seen a few cases 5 mark questions has also come, and or B, it can be a 4 mark case based question as well. Okay, a lot of good quiz based question can come from this this concept. So eye defect is very important concept. Okay, so observe the following diagram. So there are 3 eye defects, namely hypermetropia, myopia and presbyopia. You have to study all about them. Here I have taken just one example problem. Observe the following diagram and answer the questions following it. Identify the defect of vision shown. So here, as you can see, the light rays traveling for a very distant object, instead of focusing on the retina, it is focusing even before reaching the retina. So what is this defect? This is the this is called myopia. Okay, this is myopia. Now its 2 causes. What can be the possible 2 causes? First of all, the thickness of the lens increases. Okay, thickness of the lens increases, that is the lens is now having more power. It is focusing the lens, focusing the rays even before it reaches to the retina. And one more reason is that your eyes are elongated. So previously, suppose your eyes were here, now it is elongated, so they are no longer forming on the retina. Okay, so that could be the other reason of the myopia. Okay, name the type of lens used for this correction of this defect. What type of lens you will use? You will use concave lens. Concave lens, what they do, they divert the rays. So diverging the rays means after they fall in the eye lens, they focus on the retina itself. Okay, that is the use of concave lens. Sometimes they might ask you to draw this diagram as well, so you have to practice the diagrams as well. Now let's move on to the 4th concept. 4th concept is basically a combination of something, that is circuits. Circuit is basically combining Ohm's law, heating effect, okay, resistance, everything combined in one go. So here you have to solve a circuit based question. Every year in your final exam there is a question based on your circuit diagrams. Okay, so let's see the circuit diagrams in this case and question. Consider the following electric circuit diagram in which 9 identical resistors of 3 ohm each are connected. So 3 ohm is missing here, sorry. 3 ohm each are connected as shown. If the reading of the ammeter A1 is 1 ampere, okay, answer the following question. So reading of the ampere A1, what is the ammeter A1? So this is the ammeter A1 and this is the 1 ampere current. Okay, so now you have to see and answer the following question. What is the relationship between the readings A1 and A3? So what is the relationship between A1 and A3? So A1 and A3 should be the same. Why? Because this is directly connected to the battery, so whatever current is coming through the battery, that current has to pass through the ammeter A1. Similarly, whatever current is returning to the battery, the same current has to pass through A3. So current through both of them should be equal. Okay, that is the main thing, and you can mention that they are connected directly with the circuit, so current through both of them should be same, that is both of them will have the current I. Now what is the relationship between the readings of A2 and A3? What is the relationship between the current A2 and A3? Now if you see in this circuit, A2 is connected as a branch of a certain part, right? So A2 will definitely not be the same as A3, and in fact because the current is getting divided into multiple branches as it is entering here, okay, so definitely you can say that current through A2 is less than compared to that of A3. A3 is higher. All the currents coming through here, say I current is coming here, right? So I current is passing through this. Now this here at this point current is dividing into 4 equal parts. Why I am saying 4 equal parts? All of them are 3 ohms, and so basically what is happening, so this current I that is entering here, they will equally divide into all three resistors, right? Because they are equiresistant paths, so basically we can say that current through any of the part is I by 4. So definitely I by 4 is less than that of I. You don't need to explain I by 4 part, but you can explain that since current is getting divided into different 4 parts in this case, so current through A2 will be definitely less than that of A3. So current through A2, current through A2 definitely less than that of current through A3. Okay, here I made one mistake. Here it will be A1 and it will be A3. Okay, so current through A2 will be less than that of A3. Determine the readings of the voltmeter V1. We have to determine the readings of the voltmeter V1. How to do that? So voltmeter V1, we know what is the current passing. Current is passing through the circuit is 1 ampere, and this is 3 ohm, this is 3 ohm. 2 3 ohms are connected in parallel combination. If 2 3 ohms are connected in parallel combination, I taught you a shortcut trick if you are watching my videos, that the equivalent resistance in this case will be 3 by 2. Parallel and equal. How many? 2 of them. What is the value of 1? 1 value is 3. How many are there? 2 of them are there, so divided by 2. So 1.5 is the resistance of this combination. Okay, so what is the voltage drop? So voltage drop will be equals to current into, this is, if you now you can replace this entire circuit with a single R equivalent, right? So R equivalent is 1.5 and current is 1 ampere. So you just put the values 1.5, so it will be 1.5 volt. This is the voltage. Okay. Now, or there is another or question, find the total resistance of the circuit. Now if you want to do that, you can do that, not super difficult. So 1.5 volt is the resistance for this case, 1.5 volt. Now how to find the total resistance? Another, as I said, it is not super difficult. Only thing you have to consider is that here we have two equal resistances connected in parallel. So what is the equivalent resistance for this part? Say R1. R1 is 3 by 2. Now here we have 1, 2, 3. 3 of them are connected in parallel having the same value. So that R2 will be 3 by 3. And what is R3? R3 in this case we have 1, 2, 3, 4 3 ohm resistances connected in parallel. You can ignore this A2 ammeter is just to measure the current. It does not affect the resistance. So R3 is basically 3 by 4. Right? So 3 by 4 in this case, 3 by 3 in this case, 3 by 2 in this case. Now what is the R equivalent? R equivalent is basically addition of all of this, 3 by 2 plus 3 by 3 plus 3 by 4. So what is LCM? LCM I think will be 6. Okay, so it will be 3 to the 6, so 3 3 is a 9 plus 3 to the 6 plus 6 plus, oh no, LCM will be 12, sorry, my mistake. Okay, LCM will be 12. So it will be 12 and it will be 6 to the 12, so 6 3 is 18 plus 3 4 is 12, so 3 4 is 12 plus it will be 3 by 4, 3 4 is 12, 3 3 is 9. Okay, so 12 plus 18 is 20 30, 39 by 12. Okay, so this will be the answer. 3 13 is 39. So 13 by 4 should be the answer. 13 by 4 is the equivalent resistance in this circuit. Okay, not super difficult. You can follow the process and answer one step. Follow the process and do it step by step. You can do it. Okay, or if you want to do the longer version 1 by R1 1 by R2, that is also okay, but this is in my opinion is the shortcut way to solve this question. Now let's move on to the next part, that is fifth important topic, household circuits. From this also a lot of question comes. Okay, either objective, either 1 mark question, 1 mark assertion reason question, or sometimes 2 mark question, sometimes 3 mark question, up to 5 or 4 mark question can come from this part. Now let's see the question that is asked in one of the previous years. Why is an alternating current AC considered to be advantageous over direct current DC? for the long distance transmission of electric power. Okay, next question, how is the type of current used in household supply is different from the one given in the battery or dry cells? Third question, how does an electric fuse prevent the electric circuit and the appliances from possible damage due to the short circuiting or overloading? Let's see the answer. So first part is it is more efficient for long distance transmission. Obviously it is more efficient. And why? Because AC systems can use transformers to easily step up, increase, or step down, decrease the voltage level. So higher the voltage levels, okay, less is the power consumed, okay, more current, more power is dissipated. So that is one of the reasons that whenever you are using AC current, the power lost during transmission is very less. Okay, next is number 2, the household supply provides an alternating current AC where the direction of the current changes periodically, that is typically 50 Hz. Battery or dry cells provides a direct current DC where the current flows in a single constant direction. For example, 1.5 volt battery provides a unidirectional current, whereas 220 volt 50 Hz AC current that changes its direction 100 times every second. Right, now next into question number 3, an electric fuse protects an electrical circuit and connected appliances from a damage due to short circuiting or overloading by interrupting the flow of the current when it exceeds the safe level. So electric fuse gets heated up and it's burned when the current exceeds the maximum level. This is the basic fundamental of the fuse. Now if you have enjoyed this session and if you are following our 99% and 99 days, then definitely you can give this video a like, and if you have not yet subscribed to our channel, definitely you can subscribe to our channel, and in future I will be seeing you in a new sample paper that is coming next week. Till then, bye.